Welcome to the Elliott Hahn Network. I'm your host, Ronnie Lewis. The Washington Teachers Union has launched a major initiative called Learning Doesn't Stop, Lessons on TV. Let's check out ELA instructional coach Ms. Brandie Crump and social studies teacher Tyrone Shaw. Ms. Crump will discuss steps to chunk the text, while Mr. Shaw will be discussing spice in history. Lesson 2 will consist of Ms. Kearney from Ron Brown College Prep High School and Ms. Green from Anacostia High School. Let's see what we can learn today. Take it away, teachers.
Hello, my name is Brandie Crump, and I am the ELA instructional coach grades 6 through 12 at Carozo Education Campus. All right, so it's week 3 of at-home learning, and I know that you have a close read in front of you. The thing with close reads is that they are intentionally designed to be rigorous because close reads are intended to be read multiple times in order to grasp the meaning. Have you ever read something multiple times and you're like, what am I reading? Yeah, me too. I do it all the time. So today we're going to hone in on a super essential annotation strategy called chunking the text. Say that with me. Chunking the text. Give me a quick thumbs up if you've heard of that before. Yep, to some extent. So chunking the text is simply jotting the central idea or what was formerly known as the main idea in the margin of the text. In order to do that, I like to follow 3 simple steps that I like to call cut. All right, so the first thing you're going to do is circle unknown words. But because you're always striving to be a stronger reader, you want to attempt to define them with context clues as you're reading. That'll help you make meaning of the text. The next thing that you want to do is underline keywords and phrases. But you have to be super careful here because what happens if you underline too much or highlight too much? Yep, then you don't know what's important and your paper end up looking like a coloring book. We don't want that. All right. Then the last thing that you're going to do is bracket the paragraph. Going to draw a quick little bracket and you're going to jot your central idea there. It doesn't have to be a full sentence or a lot of words, just something so that when you go back to review and read, it can easily remind you, oh, this paragraph was about that. Cool? All right. And before we start the text, perhaps the most important thing, after you jot your central idea, you always want to double check that you have what to support the central idea? Evidence. Exactly. You always need evidence to support your claim or to make your argument. Got it? So that's easy. CUB, cut. Should we try it? Okay. You should have this 9th grade text in front of you, but don't worry. Even if you're not a 9th grader, this annotation strategy of chunking can be applied to any rigorous, complex text you need. Okay, so before we start, I want you to work with me. I'm going to be reading the text out loud as well as modeling my thinking. I want you to pay close attention to the things that I am saying and the way that I'm thinking because this will help you to become a stronger reader. All right. In order to counter, go against more than a century of racist stereotypes of Blacks in American pop culture, Renaissance artists have an obligation, circle, or responsibility to convey, show. So do you see, I'm trying to jot down a synonym as I go so I can make it in plainer language for myself. Have an obligation to convey respectable images of African Americans to white society. Sounds pretty important. Obligation to convey respectable images. All right. In other words, art should be used as a political means, not for its own sake. Once Black culture is accepted and integrated into mainstream culture, then political, social, and economic equality will follow. Okay, we read that. Did we fully digest it? Let me go back as a reader to double check. All right, did we do our C, circling? Yes, we did. Did we do our U? Did we underline? Yes, we did. Only the key phrases. So if you notice, I don't have everything here underlined. Okay, are we ready to do our B? What's our B? Perfect. Bracket. All right, so what is the central idea or the main gist of this paragraph? And it is art should be used for a purpose. Is that a complete sentence? Not necessarily. Is it very, very long? Nope, because when I'm going back to review, I don't want a long thing to have to read. This gives me the gist, okay? So we used our CUB. Simple enough, right? So at home, whether you have this text or any complex, rigorous text, I want you to go ahead and complete the rest of this close read by yourself. I guarantee you that if you use this chunking annotation strategy, not only will it help you to become a stronger and better reader, but it'll build your vocabulary and your confidence. All right, I really hope that this helped. This is something that you already know how to do and something that we must continue to do as lifetime learners. Thank you so much for watching. For this video and others like it, tune into www.WTUlocal6.net. Thanks.
Spice in History, Renaissance and Reformation. Our objective today is students will be able to explain how to use spice by analyzing spice definitions in order to categorize facts by spice in subtopics when annotating historical texts. So what is spice really? Well, world history revolves around major themes, and a great way to remember these themes is to use the SPICE acronym: social, political, interactive, culture, and economic. Now, I am going to go a little bit more in detail for you to show you how and to use these and what they mean. So first we have social, and social has anything to do with how gender roles and relations play out in a civilization, family and kinship, racial and ethnic constructions, or social and economic classes. So anytime you see any sort of stratification hierarchy in a society. Then we have political. And for political, we're going to be looking at political structures and governance. And an easy way to remember political is, say, anytime anything has to do with the government or what a government would do. So empires, nations and nationalism, wars, revolts, revolution, right? And so regional, trans-regional, and global structures and organizations. So just think political, government, anything that has to do with government. Then we have interactive. And so when we talk about interactive, this is one of the most complex ones of SPICE because this deals with how people are interacting with their environment. So how people are changing the environment around them, or how is the environment changing the people that live there. So it's how people are interacting with the environment. So, for example, demography and disease, right? So population, is there like a plague that pops up and wipes out a large part of that population? Migration, where and how people are moving, where people are settling down. Are they in mountains? Are they in a valley? Are they by the ocean? Are they by, a river? And then technology. So how are people transforming the environment around them using technology? And then we have cultural, and cultural is one of the easiest ones. Culture, obviously religion or belief system, philosophies and ideologies, science and technology. So this is going to be how they're inventing technology here. What new technologies do they develop or expand on? And then arts and architecture, which for the Renaissance is going to be huge. And then economic. And obviously, economic, you should just think about money, right? How are people making money? What do they use for money? So we're going to be looking at agriculture and pastoral production, trade and commerce, labor systems, industrialization, capitalism, and socialism. So let's take a quick look here on how we use spice in world history. So while you're reading a text, it is easiest to categorize facts by spice subtopics. This will help you complete your annotation of the text, right? And then your spice chart later on, which I'll show you. And so when you do this, you get a full analytical summary of the text. So it shows that you understand this text in depth. So for example, here, I am showing you how to annotate using spice. So notice here where it says, merchants gain political power to match their economic power, then use their money to buy luxuries and hire talent in a patronage system. So here I put economic, political, and cultural because it talks about writers and artists are producing specific works of art, right? And that's culture. It talks about how these wealthy merchants, right? So economic and political there, right? Gaining power as well. And again, you can see down here, I've given you another example where this one has social, political, cultural, and economic. And for example, these two here are mostly political because they deal with government, they deal with forming alliances, they deal with wars as well. As you can see, this is how you would annotate your text. And then you would come here now to use your spice chart. And in the spice chart, you are going to then transfer all of this information to the appropriate category. And I always encourage my students not to just copy the text, but to put it in their own words.
Hi, I'm Miss Green.
And I'm Miss Kearney from Ron Brown College Prep High School. We're coming to you for the High School Math WTU's Learning Doesn't Stop series.
And today's lesson will be facilitated with a pencil, paper, and a basic scientific calculator. But if you don't have one of those, you can also complete the computations with pencil and paper.
Awesome. We're just going to share our screen so you can see our PowerPoint.
So last week, we explored the math involved in modeling annual savings plans using a table. For our weekend challenge, you were tasked with setting a savings goal for yourself while being mindful of the inequities that may prevent someone from saving.
This week, you'll set a clearer vision for your personal goal as we continue to prepare you for our capstone, where you'll take on the role of a banker to determine if you would approve a home buyer for a loan.
Before we get started today, let us have a mindful minute. Let's center ourselves. Look at the visual, silently take 5 seconds to reflect, and for the next 30 seconds, respond by quickly sketching, jotting down, or verbally sharing with someone around you your reaction to the prompt below. How might the image relate to the energy or attitude we choose to bring to this experience today? 30 seconds on the clock. Go ahead and wrap up. Hopefully you took away that as we focus on building the skills needed to make our money work for us, patience and perseverance are key. Ms. Kearney, how did you feel about the problems you did over the weekend?
I felt really good, but the table was getting a little bit tedious because I wanted to see my money grow for a very long time. However, I think I figured out an easy way to do it with an equation, so I'm excited about the lesson outcome for today, where we will apply our understanding of key features of geometric series in order to build and evaluate a function representing a savings plan from the verbal description we had last week. I know our key vocabulary is annuity, common ratio, finite geometric series, initial value, interest, and multiplier. I'm hoping that you can confirm that I'm right with my process so I can make sure I know how many months it'll take me to reach my savings goal given a set interest rate, how much money I'm going to save given a set period of time and a set interest rate, and what interest rate I'll need to reach my savings goal with a specific period of time.
I can see that you're starting to see the variables that are contributing to the factors for your savings plan. I'm also really happy that you found a more efficient way to calculate your savings. But before you take us through that, can you walk me through the process of building and evaluating the function for the water problem?
Yeah, I pretty much had that process down, so I hope I'm right.
Okay, let's go to the doc, Cam.
All right, I already have the annotations from last week. So if you can hide that for me, or you can keep it there. Assuming that there is initially 1 inch of water in the tank, I set that as my initial value of water in the tank. The height of the water is going to double, so that is my multiplier. I made my initial value A and my multiplier B. Every 10 seconds was how my water was doubling. So that's my increment of time. So I put that T over 10. To build and evaluate the function, what I know to be an equation, I know that I was finding the value of the height of the water after 1 minute, which was 60 seconds. Now we already had our table formed, so I just thought about that process. To formulate, I was going to use a representation of a function. So I said my output has to be equal to my starting value, which I call A, multiplied by whatever my multiplier was, which is 2. I'm going to just go ahead and call that B. So let's make it B. Raised to X, because that's an exponential function. In that case, I knew that my output in this context was the height of the water. The height, depending on the time, where my initial value or my initial height was 1, times my multiplier 2, raised to X, which was T over 10 per 10 seconds. I wanted to compute the height of my water in the tank given the time of 60 seconds. So I knew I would have 1 times 2, and I would have to evaluate by substituting 60 seconds for T. By doing so, I can now simplify that expression by having 1 times 2 to the 6th power. 1 times 2 to the 6th power is literally 1 times the quantity of 2 times 2 times 2 times 2 times 2 times 2. Therefore, I know that if I want to find the value of the height of the water at 60 seconds, I would have 1 times 4 cubed, which is really 64. My interpretation is that there will be 64 inches of water in the tank after 1 minute.
Wow, it sounds like you have a really great understanding of that problem. Let me hide this tool as we revisit the lesson outcome for today. Are you ready to model the process of building and evaluating a function representing a savings plan?
I think so.
Well, how do you think we can be mindful while talking about the lesson plan for today?
Well, I think I had some questions in mind as I was building out my table and my function. Like, for example, what circumstances might prevent someone from ensuring their money reaches its maximum potential? And then how might someone like me safeguard myself against savings account discrimination?
That's really deep. Well, while you're thinking about that, I want you to model the problem from last time. You ready?
Yes, I'm going to go ahead and build this function, but I kind of want you to know the thought process that I had so it can make sense when I use my function. So one thing I did was I went ahead and used the function from the water tank problem. So y equals a times b to the x let me know that this was my initial value and that b was my multiplier, while x was my time or my input. That being said, my savings account would not give me the future height of the water tank output. It would give me the future value of the savings in my account, or the future value of my bank account given my savings. So the future value of my funds is noted by the present value in my account times the common ratio, which we knew was 1.0025 in number of times, n being my period. Therefore, if I had to continue, I know that the final amount deposited in my account week 12 was $100. It did not earn interest, but the money that was put in the 11th month sat in for 1 month and it earned interest 1 time. Taking that into account, I can tell that I needed the sum of the sequence for the 12 months, but I had to think about what if my money for the last month actually earned some interest. So I would have 100, but this would earn interest 1 time for the whole year. then the money that was put in the 11th month would actually earn interest twice. And the money that was put in month 10 would go from earning interest twice to earning interest 3 times. That said, I know for the sum of the sequence, originally I would have A, my initial value, R to the 0, meaning it did not earn interest anytime, versus A, my initial value times R once, initial value times my common ratio twice, initial value times my common ratio 3 times, initial value times my common ratio all the way to 10 and 11 times, taking into account my first deposit that sat in there and earned interest for 11 months. Well, I got to take into account, again, what if my last deposit earned some interest? That difference in my account will be the sum of my sequence or my series with that ratio in mind. Therefore, I would need to go ahead and subtract the ratio times the sum of my sequence. If I did the ratio times the sum of my sequence, then I know that I would have my last deposit not having the ratio 0 times, but having the ratio once. The 11th deposit having the ratio twice. This one having the ratio 3 times. This one having the ratio 4 times, all the way to this one having the ratio 11 times. And my first deposit would have had the ratio or the common interest or the common ratio 12 times. Taking my sum of my series and subtracting what I know to be the common ratio for the entire series, I know that my like terms would cancel, leaving me with A times R to the 0, or just A, and then my first deposit, A times R to the n being 12. It took me a lot of work, but I realized that the sum of my sequence minus the ratio times taking into account the interest on my last payment, if it had sat, would leave me with A minus AR to the period 12, which is n. The sum of the sequence or the sum of the series, then, I can go ahead and factor out using my understanding of distributive property to have S sub n times the quantity of 1 minus R, which is equal to, factor out the A, or what would be the initial value, times the quantity of 1 minus R raised to the n power. I would divide by the quantity of 1 minus R on each side of the equal sign. If I do that, this right here would cancel out and leave me with the sum of the series, which I know. That's equal to this formula right here, which honestly is what I use to figure out how to evaluate at my $100 deposit over the course of the year. Here's where it gets fancy. Now that I have that formula, I can actually do what you asked me to do and build this function. So the lesson outcome really starts here. Given my actual formula, which I know to be what I derived, A times the quantity of 1 minus R raised to the period n, all over the quantity of 1 minus R, taking into account the fact that my deposit was $100, I had a period of 12 months, so that's n, initial value would be A, and my annual interest of 3%, annual means over the course of the year, like you told me, I know that the interest is 0.03 divided by 12, giving me 0.0025. So all of my money and the interest is my common ratio, showing that it's compounding. Okay, so here's my formula. I'm going to go ahead and compute what would happen immediately after the last payment by going ahead and evaluating by substituting n for 12. N is my period. My initial value, my deposit, is going to be 100 times the quantity of 1 minus the common ratio, 1.0025, raised to the 12th power, all over quantity of 1 minus 1.0025. Here, I just substituted those values into the equation that I built. Once I do that, I know that I then can go ahead and simplify. I'll take my calculator, which I'm going to use my phone, and I'll take the quantity of 1 minus 1.0025 raised to the 12th power, and I'm going to divide that by the quantity of 1 minus 1.0025. That's going to give me 12.1664. So I have 100 times 12.1664. 100 times 12.1664, take that value, multiply it by the 100, and that's going to give me $1,216.64. So the sum of my series at 12 months is $1,216.64. That's exactly the same answer that we got in the table from last week. $1,216.64 will be in the account immediately following the last payment. How did I do, Miss Green?
Talk about patience and perseverance. So it seemed like you found the difference between the sum of the sequence and the common ratio times the sum of the sequence, which accounted for the multiplier as compounding the factor of the monthly deposit. Therefore, the function included the exact summation of all the values in the table and can be used to find values not included in the table via evaluation. So your function is very efficient, and it's a really great way to verify the values without tedious procedures. So what do you think? What if I told you you never even had to derive that formula?
I would be so excited. You mean to tell me you would just give me the formula and I can build the information right from what I know? All I gotta do is evaluate?
That's what I'm telling you. You ready for more problems?
Of course.
Okay, so I'm gonna invite you for our weekend challenge to use the present value of annuity formula to calculate our problem sneak peek of next week.
Okay, I'm excited. I know I can get this problem by going ahead and texting at WTUHS to 830-268-4310.
You can also get the answer key and request additional problems. Share your mindful minute.
Awesome. I know that this lesson will be translated to Spanish by Catherine Avila at Czech and Veronica Torres at Truesdale Education Campus.
Okay, so let's stop sharing so we can give proper goodbye.
All right, again, so I'm Miss Kearney.
And I'm Miss Green.
And we're going to see you
next week.